Alright, in part D, we're asked to the nearest whole number, what is the maximum number of mosquitoes over the time interval from 0 to 31, and show the analysis that leads to your conclusion. First of all, we're looking for an absolute maximum. Second of all, we have a continuous function on a closed interval, and so therefore we're going to use the extreme value theorem, which tells us that the maximum, absolute maximum, occurs at either a critical value or an endpoint. We know that at time 0 we have 1,000 mosquitoes. We know that at time 31 we have 964 mosquitoes. And so we're looking to see whether there is an absolute maximum above 1,000. I'm going to define the function m to be the number of mosquitoes on the island. And it's very similar to what we used in part C. We have 1,000 plus the integral from 0 to t this time, because we want to be able to tell at any time t what the number of mosquitoes on the island are. It's 1,000, the initial number, plus the integral from 0 to t of r of x dx, and we use x as the dummy variable there. All we need to do here to find the critical values of m then is to take the derivative of m. And from the fundamental theorem of calculus part 2, the derivative of that expression is just r of t dt. To find the critical values, we want to find where r of t is 0. And to do that, we're going to bring back the calculator and set up our window this time, going from 0 to 31 by 1, and then negative 10 to negative 20 to positive 20 should be fine. Let's see what that graph looks like. Now we can see that this derivative is positive, so that means the number of mosquitoes are increasing up to this point, and then negative, so they're decreasing, and then increasing. So that makes this point here a relative maximum, and this point here a relative minimum. So let's find out what those values are. We're going to use the 0 function again, left bound. Let's set this, say, between, if we're going to 31, so let's say it starts at 1 and going to 15, and the guess is 7.854. Now the second one, we'll find another 0, again going from 15 this time to somewhere between 15 and 30, guess, and it tells us that that's at 23.562. Now we know that at 7.854 that is a relative maximum, and at 23.562 that's a relative minimum. And since a relative minimum can never be an absolute maximum, we don't really need to worry about that particular one. So I'm going to close the calculator down and show that we want to evaluate the function, the number of mosquitoes, at each of those time intervals. Well, we know at 0 there's 1,000, and we know at 31 there are 964. We know at 23.562 that's a relative minimum. And that can't be the absolute max, so we don't worry about it. Now all we need to do is to evaluate our function at 7.854. To do that, I'm going to bring back the calculator, and right from the window that we were on, we can do second calc option 7. The lower limit is 0, and the upper limit is 7.854. That gives us 39.359, and we want to round that to the nearest whole number, so that's just 39. And you should remember that the area under that rate curve from 0 to 7.854 is the net change in mosquitoes on the island during that period of time. You still have to take into account how many mosquitoes there were at the beginning. So there's 1,000 plus 39, and so we can see that that is our absolute maximum. And that wraps up this question here. So I will close down the calculator. You can see all of those answers for the problem. All right, we'll go on to problem number 6.